Welcome to this technical overview of CFSEI Tech Note L400-25, originally published in March 2025. This note addresses a niche but critical topic in cold-form steel engineering, the use of non-bearing cold-form steel lateral force-resisting systems. These systems are non-standard and fall outside of the scope of ASCE SEI 7, which presents a unique design and construction challenge. This tech note is specific to non-bearing cold-form steel lateral force-resisting systems. If you're designing a bearing wall system, there are separate tech notes for both wind and seismic cold-form steel lateral force-resisting systems that you will want to reference. First, let's discuss what these systems are. A non-bearing lateral force-resisting system is designed to resist lateral loads only. It does not carry gravity loads and is intentionally isolated from the building's vertical load path. This is achieved using slip connections, typically slotted tracks, clips, or another mechanism that allows vertical movement to prevent unintended axial loads on the stud. While non-bearing lateral force-resisting systems can provide lateral resistance, they also introduce some very significant challenges. The tech note is organized into several key sections. Introduction and definition of non-bearing lateral systems. There is a brief statement about viability of these systems. There's a discussion of design challenges that need to be overcome. There's some guidance on seismic design coefficient R values. There's some detailing strategies for various wall configurations when you do need to do these systems, and a brief discussion of multi-story considerations. Finally, there's a summary and two design examples that go into the specific components unique to non-bearing lateral force-resisting systems. Let's get started with the biggest question. Are non-bearing cold-form steel lateral force-resisting systems viable in my project? No, they are generally not. For new construction, non-bearing CFS lateral force-resisting systems are not recommended. There are some niche applications these systems can fill, such as historical retrofit, but on new construction, these systems are expensive, unusual, and difficult to execute. The tech note does a deep dive into the issues with these systems as well. But to summarize, non-bearing lateral systems rely on slip connections to isolate the vertical deflection. But these connections are not typically rated for any in-plane lateral loads. This creates four major challenges. First, slip connections and lateral load transfer. The clips and connections are not generally rated for lateral force-resisting system loads and often not tested in plane at all. Secondly, the seismic design coefficients are unclear. ASCE 7 provides limited guidance on what R, overstrength, and CD values to select, but what most designers want to use out of the tables is not actually valid. There's a separate discussion on this later. The detailing challenges proposed by these systems also are difficult. Properly detailed, these are incredibly complex and expensive details, all while being built by somebody who has most likely not had to build a detail like this before. Finally, there is a risk of misinterpretation by future occupants or contractors. This is a significant one that is difficult to quantify. As this is an unusual system, when modifications to the structure are later made, it is unlikely the new design team will understand that these components are critical. By having slip connections, a cursory inspection would quickly lead future teams to assume that these walls are purely enclosures. The issues combined make these systems difficult to justify without further extensive testing and documentation that just currently does not exist. The tech note contains a large discussion on seismic parameters, as seismic design is particularly problematic. ASCE SEI 7 does not provide clear R values for these systems, and AISIS 400 imposes additional strict limitations. These configurations must fall under steel systems not specifically detailed for seismic resistance, i.e. R equals 3, which is not permitted in seismic design categories D, E, or F. The tech note has a full discussion on the issues with using the other potential ASCE 7 categories. However, the testing and data that's used to create these systems does not cover non-bearing cold-form steel lateral force-resisting systems. See the tech note for additional information on this subject. This is Figure 2 from the tech note. It illustrates the applicability of AISI S400 provisions to the non-bearing cold-form steel lateral force-resisting systems. It highlights the limitations imposed by seismic design standards, particularly in seismic design categories D, E, and F, where these systems are not permitted. The figure reinforces the tech note's recommendation to avoid these systems. These systems are only permitted in seismic design categories A, B, and C, and only then for select cold-form steel lateral force-resisting systems. Even in these design categories, the specific detailing requirements that are later posed in the tech note must still be met. The tech note does cover recommendations to both engineer of records and delegated design teams. If you're the engineer of record, the general recommendation is just to avoid these systems. Pick a system that is complementary to the gravity system of the building, i.e. you have a structural steel frame, use moment frames, use brace frames. There is no practical reason why these systems should be incorporated with non-bearing cold form steel lateral force resisting systems. If you fall under that niche application mentioned earlier, such as a historic renovation, the engineer of record must explicitly define the lateral force transfer with load-rated components. It is the engineer of record's responsibility to provide this detailing in a thorough manner without vague statements such as detail bypass clips for in-plane capacities, which is not actually a possible situation. These are complicated, detail-oriented systems that require complete ownership by the engineer of record for general performance integrity. If you're a delegated design team, RFI the system to request a change of lateral force resisting system to one in line with the gravity system, i.e. moment frames, brace frames, etc. If it's determined that the system must remain as a non-bearing lateral force resisting system, verify if the detailing is adequate. If the detailing is inadequate, RFI the EOR to detail properly. Only design after sufficient info has been provided by the engineer of record, as the engineer of record retains liability for the general performance of the system. If you need to design these systems, the tech note outlines the primary configurations and approaches that are possible. In all cases, there are two primary concerns: maintaining the slip connection to ensure that these components are not taking unexpected gravity loads, and ensuring a complete load path. The engineer must ensure that there is a continuous load-rated path that goes from the diaphragm through the slip connection all the way to the lateral element. The tech note provides dedicated sections for each of the four primary non-bearing wall configurations: infill strap, infill sheathed, bypass strap, and bypass sheathed. For each type, it outlines critical design considerations, required performance conditions, and offers detailed solutions aimed at preserving structural integrity and load transfer capacity. In all cases, maintaining a vertical slip connection while ensuring a complete lateral load path is essential. These are not exhaustive, and there are other potential details that could certainly be come up with, but is a collection of details that are possibilities. Additionally, the tech note includes two examples of a full calculation specific to the unique considerations of the non-bearing lateral force resisting system. Summary: non-bearing cold form steel lateral systems are not recommended for new construction. When used, they require intensive detailing, careful coordination, and clear documentation. Alternative systems that align with the building's gravity system are typically more practical and cost-effective. For full technical guidance, refer to the complete tech note L400-25 available from CFSCI. This video provides a high-level overview, but the note itself contains detailed engineering insights necessary for proper application. Thanks for watching. For more resources, visit cfsci.org.